Hello everybody, welcome to my new live stream where we are creating an entire game in C from scratch. This is the episode 11 of our series, and if you have been following along, we have come a long way ever since we started with a blank C file. So we're creating everything here on stream, and let me show you what we have so far. So this is the game that we are creating. We started out as a breakout clone, but then quickly started to adding more interesting stuff. So this level, we added some power-ups. Okay, and we played around with the gameplay a bit. Yeah, this one's pretty cool. Okay, and in the last stream, we finished our rendering kind of improvements, right? We did bitmap rendering, we created like this force field effect, we created all sorts of stuff. And hopefully, this time, we're going to create the audio system. Well, because I don't know if you guys can hear, there's no audio in the game. So that's the goal for today. If you want to follow along, you can go to the itch.io page, and then you can download for free the game and the source code. So you can download the game now. It's a zip because now we have files, have like data files. And then there's also the source code that you can download and play around with. Do whatever you want, learn and all that stuff. And all of the episodes are available on YouTube. So you can come here on YouTube and watch from the very first episode all the way to where we are now. Hopefully to beyond as well. Okay? Now, let's get started. Okay, I have this note here that I played around a bit and I found that it's hard to see the ball UI in the Pong level. Not that we're worried about that too much right now, but I'm going to just write it down so we don't forget it later. So, UI. Okay, now I think I'm going to delete these guys since we already did this. Okay, so the audio. We can spend like a whole week or a whole month just on the audio system, but let me like state some goals of what we want. Now we want to play some like any audio. Let's do like any audio. That's the first step. Then play an audio file. Play several audio files. Like be able to pan the audio. It means like we do like left and right panning to do like surround stuff. Stereo stuff should be the right name, right? Then we should be able to pan and then be able to change the pitch for the audio. So this is like what we really wanted in our audio system, and then we can actually like implement sound effects. And I don't know how much we can do today. Hopefully we can do enough just to get started in the game. And then we're also going to implement like music later on. And then we can start doing like reviewing some of the points that we're going to write today based on the specific demands. But that's the basic idea. And I have written like a little cheat file here where I have like the main stuff we're going to need today. Because we are going to use DirectSound as a library. And using libraries are kind of finicky because you need like a lot of like know which calls you're going to do and things like that. So I have written that, and I may take a look at that every once in a while. But hopefully we'll be able to do that pretty smoothly and then start doing like our own stuff. Like if you manage to play an audio file, everything from down here is like our stuff. This is like the library. And yeah, maybe we can get along pretty well. So first of all, I'm going to include the library. I'm going to go to the Windows platform, and we have like file.io. And let's do like this, like the callback. Let's see if we have anything else. Let's do like callback and name. Okay, and now I'm going to create an audio section here in the file, and I'm going to do like init audio, Win32 init audio. So we are going to first of all include the dsound.h, which is the library that we're going to use. Okay, and yeah. However, we also have to load the DLL because we can't statically link in we've been statically linking everything so far. Yeah, we've statically linked with user32 and GDI32, but now we are going to have to load the library as a DLL. So I'm going to like let me show you guys the documentation for get proc load library. So that's what we're going to use. Yeah, H module. Just going to call this function, pass out the library name, which is just dsound.dll, and that should be in everyone's computer. So, and that's called like dsound.dll. Okay, let's see. Okay, and we're gonna have a ton of ifs here. So if we don't have a dsound.dll, and then we can go like step by step. Maybe we should like assert 0 and then return. Yeah, okay, because yeah, then we can do like better errors later on. So now we're going to get the proc address inside the DLL, right? Let me show you guys this call. We're going to pass the call name and the module, and then we're going to return a procedure to us. So the module is the dsound DLL, and the procedure name that we need is DirectSound create. That's the only thing we need from the DLL. All the other ones are going to be based off that. So the DirectSound create. Now let's go to the DirectSound create, and we need a type for that. Okay, so this is what we need. So we're going to type def here, DirectSound create. Missing type specifier. Well, how am I supposed to do the type def? And every once in a while, I may actually cheat a little bit more. And yeah, and check out how we do the in the other code. Okay, yeah, but I don't think we can do that. Yeah, we can't. Let's do like DirectSound create. Okay, now this is the call that we're going to get from the DLL. So we're going to create a DirectSound create. Let's call that DirectSound create. It's going to be equal to that. And we have to cast to a DirectSound create pointer. Okay, that looks good. Now we can probably do this as well. And then we're going to call that. And the way it works on DirectSound library, we have this like if succeeded macro that we can pass like our calls. Like we're going to go like DirectSound create, and we need to call that. And let's see what it needs. Yeah, it's going to need LP GUI GUID. Let's do like 0, and we need a pointer to a DirectSound, and this is like the structure we're going to use to interface with all the other functions. So DirectSound, let's just set it to 0. I don't know if I need it though. DirectSound, and yeah, I don't know if I should pass like the pointer or the pointer to the, yeah, it's the pointer to the pointer, so yeah. And then this guy can 0. Okay, now let's try to compile and run and just see if we manage to get this far in the library. Okay, now let's go. Well, we should also call Win32 init audio. And if everything works out, this stream, next stream, we are going to do this one. Yes. We are going to do the multi-threading and make the audio async. But for now, let's do one step at a time. So Win32 init audio. Let's see. Well, nothing happens for a start. Yeah, let's. What? Yeah, okay, we have to turn off the optimization. Okay, yeah, let's turn it off and let's see now what happens. First of all, we try to load, and we do load. Looks good. Then we try to get the proc address, and we do have an address. Now let's try to create the sound, and we succeed. Now this guy, the DirectSound, is a pointer to a struct with all the info we need now to actually start building the objects we need. And what we need is actually two things. We need one thing, but to get that thing we need more things. So we need a sound buffer, just like we did in the very first episode that we got a render buffer to draw our graphics. We're going to get a sound buffer from the library. And the way the sound buffer works, it's a fixed amount of time, because the problem with audio comparing to like graphics is that audio is continuous. Like graphics, you can just display a picture, and if everything freezes and it works like that, that's okay. But the audio has to continuously update. You can't like freeze the audio. That'll like stop in the middle and that'll probably sound weird. So the way it works, we have a fixed buffer that, let's say, is like 1 second. It's like some fixed length, right? And then we start, I don't know, filling that buffer with our sounds, right, that we mix. When they hit the end of the buffer, it just loops around to the other side, so it starts overriding the beginning of the buffer. So it's a circular buffer. And the thing is, and that's the tricky part of doing sound, we're going to get to in a second, is that we want to write as, I don't know, as short a time as we can. Like, we want to write just a couple of samples or frames, let's call them that, because we want like not a lot of delay. But if you do write just a little bit and we fail to write when that finishes to play, then we're going to get like weird sound here. So we always have to keep ahead of the play cursor, which is like what? Imagine like a train that always is moving, and that train is the audio, let's say, hardware, right? It has to keep playing something, even if it's nothing, it has to keep playing something. And we have to now lay the tracks in front of the train, and we want to lay them as closely as possible because we don't want any delay. Because if you lay them way ahead, like let's say we lay this track here, and the player's here, and then like the player shoots, and we expect like a shooting sound effect. The shooting can't happen here because we already wrote all this stuff. So we probably want just a little bit delay. So we want the train to be just close enough so we can lay the tracks in a like updated fashion, but just far enough so we don't miss it. So okay, that's the basic idea. So how do we get the buffer? We can use these create sound buffer calls. Let me show you guys the docs. Let's do like create sound buffer, and that's what we need, yeah, to create a sound buffer. However, we need to create actually 2 sound buffers, because that's how it works. One, which is called the primary buffer, we are not actually going to use. That's mostly for like legacy reasons that's there. Because nowadays Windows does all the stuff for us. We don't write directly to the hardware. So we have to create the primary buffer and do nothing with it. Then we create the other buffer, which is what we want, right? So yeah. And the way we're gonna create the buffer, let me just copy this guy, is that we need a couple things. So, and actually this call, we're gonna call from the DirectSound, and it comes with a virtual table, so it's a long pointer to a virtual table. I think that's it. I'm not entirely sure. But we need a couple things. We need this guy, which is a pointer to a DS buffer description. So we need a buffer description. Okay, now, and let's fill that up. And all we need to do actually, this guy is set the size to the actual size. So buffer description dot size, the size of buffer description. And we also need flags. And yeah, we're gonna do the primary buffer for this first guy. So buffer dot dw flags. I think that's all we need. Missing semicolon. Yeah. Okay. Long pointer to virtual table. Maybe it's like this. Let's go to the, let's see how this guy is specified, so you can know the virtual table inside. Well, I think this is going to be another cheat. Right, LP VTBL. Oh, well, we forgot to do one thing, but yeah, just set the cooperative level. The thing I saw it, right? However, I don't think LP VTBL. Yeah, okay. So I think that's what we need to. Yeah, but before we do that, let's set the cooperative level. So same thing, but now we're going to do the call in the new way. So we're going to do like DirectSound LP VTBL, so it's pointing to a virtual table, and we're going to call set cooperative level. And this call is just like to set which window we are using, right? So window, we need to pass the window here, so hand into a window. And then we need like some flags, and I think we need like maybe we're gonna get exclusive, or like in the other code example, I think I passed something like priority, and yeah. And even though the documentation doesn't say, in the C version of the DirectSound, we do have to pass the DirectSound to every call. Yeah, I think that's going to be reasonable. Let's see. LP VTBL is not a member of DirectSound. Let's debug and see what we have in our DirectSound. I think that's going to be easier. Init audio, let's pass the window. Yeah. So our DirectSound, well, let's see if we can access this guy. DirectSound. Oops, I think we got that. Maybe we just call the methods and we don't need the v table. Yeah, let's just straight up call. straight up call the set cooperative level. See? We have to do through the vtable. So it's a long pointer to a virtual table. Okay, I guess I just misspelled it. VL. Okay, so let's keep going. Now, we should be able to create our first guy. Right? So we should pass the pointer to the buffer description. Then we should pass a pointer to a DirectSound. Let's call that primary buffer. And okay. And then, well, I think this guy, don't care. Okay, incompatible. Okay, yeah, the first argument, again, has to be the DirectSound. Okay, that looks correct. And we can also test like if it succeeded again. And let's do like and let's see if we succeeded or not. Okay, we did succeed. Now we have a pointer to a primary buffer. But like I said, we actually need the secondary buffer, which is the next one we're going to create. And for this next one, I don't even think I'm going to do it like this. Yeah, and for the next one, we also have to specify a wave format X, which is basically, you know, the specification of the kind of buffer we want. Just like we passed our bitmap info, said that we want like 32-bit with RGB with this width and height. I'm going to do the same thing for the audio. And let's see how this guy is specified. Yeah. So we have 15, like format. Which format do we want? We want PCM. So let's do one at a time. So wave format dot w format tag equals this guy. Syntax error. Okay. Number of channels. Need 2 channels. We're going to do stereo. Samples per second. So I don't know if you guys know, but like the way, just like the pixel is the most basic unit of graphics, audio deals with samples. So we draw like the waveform like this, which is like we usually see the audio, right? The way it actually is stored is like points in this curve, specifying, you know, how it looks in certain point of time. And these points are usually signed 16-bit integers, but there's also like float, like 16-bit float or anything like that. But the number of samples we're going to do is, let's say, 44.1K. So when you say like, oh, this audio file is 44.1 kilohertz, that's what it means, how many samples there are in 1 second. So let's go back. Average bytes per second. And you know, that's why I made my notes. The average bytes per second, let's see, it's going to be 16 bits, right, which is like the size of this guy, the size of a 16-bit integer, which is how many bytes we have, times average bytes per second. So yeah, times this guy. Well, just check. Should be the product to the samples and the end block line. Okay, so no, actually you're not right. I'm gonna leave this guy for later. Hey, can I show my programming server? What do you mean by show your programming server? I mean, drop in the chat, Discord server? Go ahead, man. That's cool. No problem. Okay. Now we actually need more stuff. The block align, and let's do like the bits per sample. That's gonna be the 16 bits per sample, right? Yeah. Okay. That's your my secret. Okay. Thanks for sharing, man. Maybe I'm gonna check out later. And for everyone that's watching, want to check out Ox Hunter's Discord server, programming Discord server. That'll be pretty cool. Okay. So 16 bits per sample. And now we can do these things like the block align, things like that. Like the block align is a, yeah, now I'm going to cheat and look at my reference. Right. The block align is the number of channels, so let me code it like this. Number of channels times the bits per sample divided by 8, because it needs like the bytes. Okay, that looks reasonable. And now we need the last guy, which is this guy. The average bytes per second. And that is the samples per second. Yeah. Times the block align, which gives us how many bytes we have. Okay, and the size in bytes, this ratio can be used for non-PC. Percentage 0. Yeah, this guy can be 0. Okay, so we have our wave specification, and now what we're going to do is create our buffer, really. Yeah, so it's going to be pretty much the same thing, but in fact, just like we created our render buffer here for the game to use, I think I'm going to create like no, the game's not going to use this, but we do need a global though. Yeah, I think it's going to be easier. Yeah, to create like a sound buffer. Okay, and now we're going to create. Yeah, but also we need to like reset our buffer description, because it worked for the primary buffer but not for the secondary one. So the flags, we need new flags. And the flags we need, let me go back to the documentation for this guy. And the flags we need, let's see, flags. Yeah, we have a lot of stuff we can play around with. Like, we're going to do the mixing ourselves, so this pan and control stuff, we don't really care. But this is pretty cool. The global focus means that it's going to be playing even though we don't are the primary window. And I think we're going to set that. Okay. And let's see what else we need. The size, yeah. Flags, buffer bytes, yeah. So the buffer bytes are going to be equal to, let's say, 1 second. That's what we did the first time. It's going to be like the samples per second times the 16 guy times the number of channels. And you're also going to store these helper variables like, oh, how many bytes we have in our buffer, things like that. Buffer description redefinition, yeah. Okay. Now I'm gonna have to cast that. Well, yeah, let's cast that too. LP. No, it's just the DS buffer description. Okay. Now, let's see if we need something else. And we do need, also in our buffer description, yeah, the buffer bytes. And we're going to pass the wave format X that we specified up there. Yeah, this guy here. would be equal to a pointer to the wave format. Okay, now let's see if we succeed calling this guy, and it's probably a search at this point, like success, else like invalid. Do we have like invalid code path? Yeah, we do. Okay, now let's see if we initialize everything correctly. Okay, that's a success. Well, it was better than I expected. So now that we created the buffer, this guy, we should be able to, first of all, write to it and then play it. So I'm going to do like an internal void to fill sound buffer, just for testing. And then we can do like an internal void. And let's also do like win32, just to make sure that our namespacing doesn't, well, C namespacing, right? So win32, and we are going to like update sound buffer. And actually, we don't need to do anything here, honestly. All we're gonna do maybe is just, yeah, we're gonna fill and then play it. Okay? Yeah, it makes sense. So in order to fill the sound buffer, what we are going to use is a function called lock, like, let's do like direct sound lock. Yeah. This is the function. We have to lock the sound buffer for writing, and then we're going to say, okay, where do you want to write? Where your starting position and then a number of bytes. And I don't know if you guys remember, but I said that we're going to use like a circular buffer. That means that maybe we want to lock from this position half the buffer. So how are we going to do that? They're going to return to us 2 positions. So they're going to say the region 1 and like possibly the region 2. If we are to wrap. So we have to do this loop like in 2 possible regions. Okay? So the lock. Let's just test like if succeeded. The lock. And the lock, we're going to come from the sound buffer. Sound buffer and same thing, long pointer to a virtual table. VTBL. Lock. Okay, and let's do like the whole buffer. So, let's do like sound buffer dot size. Yeah, we're gonna store that, and then we need a couple of variables. So we're gonna do like region 1, and then a D word for like region 1 size, and same thing for region 2. So we're gonna pass the audio pointer. That's gonna be the region 1. Region 1, and then we're gonna pass a pointer to the region 1 size, and the same thing for region 2. And the flags, I don't think we need any flags. No, we don't. Well, we could pass entire buffer, but since we're not going to do the entire buffer every time, let's see if this works. Okay, now possibly now we have these guys, and let's just keep going step by step and see if we do have these guys. So size, not a number. Yeah. And you know what? I think I'm going to do something like sound buffer, and we're going to do the same thing as we did here. We're going to have a platform non-specific and a platform specific part. Well, it actually doesn't matter that this is platform non-specific because the game's not going to use it. Well, maybe the game will. Yeah, let's make the game use this guy. So we need a couple things. Now, first of all, let's do one thing at a time. All we have is the size. Maybe size. Buffer size in bytes. Okay, and the platform non-specific is the is this guy. Platform specific party. This is like the buffer. Yeah, and then we're gonna do sound buffer dot buffer. Sound buffer undeclared identifier. Oh great. Yeah. Sound buffer. D word. Yeah. Well, same thing. We have to pass firstly sound buffer. Oh, not the sound buffer. Maybe the directs. Yeah, sound buffer. Okay. Okay. Region 1. Size. Undeclared identifier? Yeah, I call that result 1. That's not gonna help. Function pointer 2. Yeah. We do have the last argument that we chose to ignore, but we do have to pass 0. Okay. Now I have to call the fill sound buffer, and then we're going to fill, and then we're going to try to play. I am going to warn you that today is an audio day, and that's an audio implementing day, so we may have a lot of stuff going wrong, which probably means you guys are going to hear weird sounds. I am going to try to warn you and probably like turn the volume down here so you guys don't go deaf and then sue me. But you have been warned. So the sound buffer, we're going to call that play. So we're going to do like direct sound play. MSDN. Yeah, this guy. So reserved must be 0, priority, lowest priority 0, the highest priority is this guy. Well, I should probably do like the highest priority, right? Flags and if it's looping or not. Okay, so we're gonna set it to play continuously and just expect that we manage to call that, to fill that on time. So reserved 0, priority, yeah, let's do like the full priority guy because we are a game after all, right? Just like FF. Okay, flags 0. We're not going to call play first because we're not filling that with anything. So don't need to worry about that for now. Let's just try to see if we get this guy successfully. Yeah. Okay. No. Sound buffer. Yeah, we have to fill that. Well, that's weird because we changed what sound buffer is. Yeah, this guy should actually be. Oh, we passed the primary buffer. Yeah, so that was a mistake. So we're going to do sound buffer dot buffer. Okay, nice. Okay, let's try that one more time. Okay, and we failed again, but at least we didn't crash. Not sure that was good or not. Okay, so we're asking us to lock, and it failed the call. Well, we are asking 0 bytes, right? So I can't argue with that. So let's do like some of the sound buffer. Filling sound buffer dot size is going to be equal to this guy. Number of channels. Yeah. Not sure. I think I'm gonna do like this, and then we're actually going to do sound buffer dot channel count and a samples per second as well. So samples per second. 144. Oh, let's do like, no, yeah, that's right, 40, 41, 44. Yeah. Okay, sound buffer times per second, and this one's gonna be the sound buffer channel count. Okay, and let's do this guy up here on the top. It's like the sound spec. And then this guy is the sound buffer channel count. This guy is sound buffer samples per second. Oh, this guy, I think I'm gonna just hard code that because we are assuming we're gonna use size of this guy. Yeah. Okay. Yeah, and the buffer bytes now is going to be the sound buffer size. Yeah, we don't have count, so let's do like channel count, and let's do, which one was that? The other one? Samples per second. Okay, from int to word. Yeah, well, whatever. Okay. Now, let's see if we correctly are asking for like, yeah, a lot of guys. Okay, now we have successful thing like this. Now, what I'm going to do is go through all the samples, which is going to go like from 1 to the region 1 size, right? And let's do a square wave. Let's fill this this buffer with a wave like this. Okay. Let's do like square, and let's do like square frequency. Okay, and this let's say it's like up equals true, just for testing. And if up, let's say that sample is, and this is like the volume. This 500 is the volume. Well, not the volume. Let's say the intensity of the sound. Okay, now we want to set the region 1, so we're going to do like, let's do like U16. I'm sorry, S16. Let's do like sample. We're going to start that with the region 1. And we're going to do like sample is going to equal to, oh, we already have sample. Let's do like, let's call that at. This guy's the sample. Yeah. Okay, and at is going to equal to sample. Sign unsigned. Yeah, let's do a D word. Okay, and we're going to do the same thing for the region 2. Okay. Okay, now for every sample, we are also going to increment the square frequency. And if the square frequency, this is going to set the pitch of the sound. So if this guy, I'm not sure, if this guy is greater than, I think it's like 400 something, it's close to the middle A note, then I'm going to set the square frequency to 0, and I'm going to, change the up. Yeah. This is just for us to test with a square wave so we can hear something. Okay, so I am going to explore this territory first. I'm going to put my little earbuds, and I'm going to turn the desktop audio off for you guys, so you guys have no chance of going deaf. And maybe, if it works, I'm going to go set the volume back up for you guys. And we also have to do the play. Yeah. Play is not a member. It is not. pass sound dot buffer. Okay, now let's see. I'm going to turn the volume really down just in case I don't go deaf. And let's see if we have something. Okay, I don't hear anything. Let's just debug to see if we fill that with something. So right here, let's see. First of all, let's see. Do we have valid data? And we have a valid point for this guy. This guy is the whole thing. So we are supposed to fill. Well, we're not. Yeah, we're not incrementing the at pointer. So we're actually just filling the first sample, and that's not gonna do anything. It's not even like video where just filling one pixel, you can see the pixel. Audio, you have to feel like the difference between them to see like for the airwaves, for the air to vibrate, things like that. Okay, let's go one more time and let's debug before we try to hear anything. So our region is correct apparently. So we're gonna run and we're gonna set the sample to 500, and then we're gonna increment that. And what we expect to see, I'm going to see here in the watch window, I'm going to cast that to x16. What we expect to see, let's see, like 64 of those. Well, I need more than 64. So we're filling these guys with 500, but if we get to like this point, okay, and we probably did more than access violation. Okay. This size is in bytes. So I'm going to probably have to calculate like a D-word region 1 sample count, which is this guy divided by the number of bytes per sample. And I don't think we have that in the sound buffer. Bytes per sample. Same thing has to be done for this guy. Then we're going to do the region 2 sample count. And this is going to use region 1 sample. Oh. Okay, now let's add this guy. Bytes per sample. And we also have to set them. Bytes per sample are going to be the channel count times the size of this guy. And now we can probably just reuse that a lot of times, like this sound buffer times bytes per sample. And let's see, where else? No, that was the only place, I guess. Okay, again, let's see. We are filling these guys, and let's try to go down here, and we don't crash, which is a good sign. Let's see, like 1,000 of those. Okay, so we're setting both 500 and minus 500. So maybe now we should hear something. Well, I don't hear anything. I don't hear anything. We could play around with these values, but these sound kind of reasonable to me, I think. What I could do is try to turn them way up, and the frequency, yeah, the frequency. We can probably turn that a little bit lower as well. Should we expect like a bassier sound? No, I'm going to try to turn on my speakers that have a better. Okay, let's see if our play succeeded. Let's say if it didn't succeed. Let's say we crash. Yeah, and we do crash. Okay. Play sound buffer 0 0. Let's see if we're missing something in the play. Oh yeah, actually we should set that to looping. Not sure if that's the problem. And we should probably just try setting this guy to 0 at first, then we can try making that a priority. Let's see. Can you guys hear that? It's going through my speakers, and I think you can hear that. That is somewhat working. So we do hear a wave. I don't know, maybe I'm gonna just keep that on my speakers for now. And then later on we can do like desktop audio for you guys. These are just like sound waves. Let's see if this was the problem. Yeah. So apparently you can't set a priority high. That's no problem. Anyways, so why do we have just one guy playing? This sounds like a really crazy alarm. And the answer is because since we're doing stereo, we should really like do for both guys. So when we are running through our loop, which we're gonna do in a while, this should like do like the right channel and left channel, or the other way around. Not sure. Can you hear that beautiful sign? I'm gonna make it run through your speakers. Let's see if it's, I don't know if it's too low or too high. Let's see. Did you guys manage to hear that? We should also be able to hear that there's a small problem when it loops around. So what we are drawing is actually this guy. It's something like this. And yeah, we can hear. Okay, thanks Puzzle Dev. So the problem is, when we loop around, we should actually write from this point and not like just infinitely loop. That's not a problem we're gonna have since this is just a test. So for our fill sound buffer, which I actually want to do is I think I'm gonna set that to 0. So I'm gonna make no sound in the beginning. Okay, just so we can clear the sound buffer. Maybe we should call that clear sound buffer, and then the fill sound buffer is gonna be different. Okay, up. Yeah. Okay, so this is gonna be the clear sound buffer, and now we should have nothing, and we have nothing. Now we're gonna do the fill, but the fill, as I said, has to be done every frame. Okay, so this is what we're gonna do now. We're gonna start building the actual thing. So let's go to our game. We managed to play any audio. So that's mission 1 succeeded. Mission 2, play an audio file. So this is a little bit trickier. I mean, just a little bit. So I have from the other project, let me check out this here if I have to open that here. I have from the other project like a song that I did. I'm gonna do like new ones for this project as well. Yeah. So let's try to play that. And if you manage to play that, this audio file, we're gonna be, in a great position to finish our guide. How are we gonna do that? I'm gonna first of all copy that to the breakout data folder. I'm gonna call that like test.wav. And just like we did in the image thing, where we use the library, we're gonna use the library to read this guy. But this library I wrote myself, so I think it's gonna be easier for us to debug if you have any problem. But I am going to run through the code. It's not that big. The library is going to decode the WAV file, which is not that hard, and it's going to give us a uncompressed sequence file. Okay. So let's see the code, and we have like a WAV importer. Yes, we do. Let me throw that on the breakout code folder. Okay. So breakout code WAV importer. So this is how we use the WAV importer. We have a loaded sound struct, which has a sample count, channel count, and the samples. And then we just do it like this. It uses the OS read type file, and it doesn't free memory. Yeah, or we can load from memory. I think I'm gonna prefer to load from memory. And the file spec, okay, so it has to be .wav PCM 16-bit per sample, 1 or 2 channels, and it interleaves right, left, right, left, right, left, which is exactly what we need. Okay, and this is the code for doing the thing. And let's see, when we load the file, yeah, we just call it the OS entire file. But I think I may actually just delete this guy from our use. Well, yeah. Now let's see. Let's also import here our wave importer.c. And actually, I should maybe call that .h just because it's a library and didn't write that on stream. Yeah. I'll call that wave importer.h. Just so we can later on count the lines that we wrote and count the lines that we didn't write. But it's not that big a file. Yeah, it's like 200 lines. Okay. Now that we have a wave importer, we can go back to the game, and just like we did the bitmap guy here, we're going to do a loaded sound and call that test sound. And let's do like the bitmap, same thing. So loaded, oh, did I call that sound? I think I did. Load WAV, and we're going to pass data test.wav. And we're going to go step by step. Sound, well, loaded, test sound. Okay. Load WAV undefined. Oh, from memory. Yeah, well, let's actually keep this guy. I deleted. Oh, that's okay. Yeah. Loaded sound. Load WAV. Char file. Then we're gonna do string file name equals OS read entire file name. Then we're gonna do load wave from memory file and return. Yeah. Let's see if we have like a somewhat decent. And let me just check out this really quickly. If I actually allocate memory, or if I just copy the samples. Result. Yeah, I just copied the samples. Yeah. Okay, so I don't free. Let's go back with the documentation. Equals load wave file.wave. Calls OS read entire file and doesn't. Yeah, that was kind of a waste of time. And doesn't free. Okay. Perfect. Now let's go back to the game. I don't know, the game tab, I think I'm going to pin it. doesn't want at all to be stuck on the Visual Studio window, even though I did that like 3 times. And I tried to pin that. Okay, let's see if we have a test sound. Test sound. Sample count, channel count, and samples. Let's see the samples. Does that look reasonable? Yeah, I think it does. 3. Yeah. Okay. Now, what we need is to call a function like, I think I'm going to create a new file and do like audio.c. I'm going to do an internal void. Let's do like update game audio. And the game, let's maybe call that update game instead of simulate, because we also do all sorts of stuff here. So, Win32, simulate game, let's do update game. And then let's also do update audio. Yeah, let's do it like this. Update game audio. And then we should also include audio.c. Okay, now what do we want to do? Update game audio. All we want to do for the game is going to pass a memory that the game is going to write, and we're also going to pass a the count for the game. Right, and you know what? In order for the game not to worry about the circular buffer thing, I think I'm going to allocate here in the init audio. Yeah. Yeah, I'm gonna do like sound buffer dot. I think I'm gonna change the name to from buffer. Yeah. Well, let's do one thing at a time. From buffer to like platform buffer, just so the game doesn't worry about that. And then I'm gonna have a buffer, which is for the game to worry about. Well, you know what? I think this guy really should be out here. So this is the game sound buffer. And I think I'm gonna do the same thing with the video. It's gonna be cleaner. Yeah. Yeah. Let's get this compiling first, and then after this compile, it's gonna clean up the. You guys understood, right? The rendering. Okay. Okay. Sound buffer, and let's also put this guy up here in the platform comment. So platform services to the game. Yeah, I'll do like input. Then we do like audio. Then we do like rendering, maybe graphics. Let's do rendering. Okay. Okay. And for the rendering, let's do the same thing. So this guy is just going to be like Win32 stuff. Yeah. Okay. This guy should be here. Bitmap info. It's gonna be clean, I think. Okay, kind of like that. Let's see if we still get what we expected we do. Okay, now let's go back to our audio thing. Now we have this structure, the audio stuff, and we're also going to pass let's do like samples, then samples to write. Okay, that's all we're gonna, and this is what the game cares about in the, this is more like for info, and this is more for doing stuff. Okay, now when we init audio, we're also going to initialize the samples with a virtual alloc. Let's just copy that. And we have the size, so we're going to do sound buffer.size. Yeah, well, that's about it. Okay, so what we need now is to know how many samples should we write in a particular frame. So the idea is called update game audio, and we pass out the sound buffer. And then we do like game sound buffer, do like sound buffer, correct? Now the only thing we're going to do here is going to be pretty much, it's going to be even an easier thing. We're going to do like an at, which is sound buffer dot samples. Then we're going to do like for every sample we want to write, sound buffer dot samples to write. Then we do like at equals. So that's the basic idea of what we want to do. The problem is, how do we know how many samples we want to write? Because I told you the problem that we had. Like, how much should we write? Should we write like a lot, a little? Okay. So that's where a more tricky thing comes into play. And that thing is trying to get the idea, trying to calculate that. So here we're gonna do and like update audio, and then we're gonna clean that up later on. But for now, we're gonna throw all this stuff here. So what do we need when you're updating the audio? We firstly need to know where we are at, which is like the play cursor. This is where we are playing right now. So let's see if we wrote something like this. This is where we are playing, right? But Windows also gives us a write cursor, which is saying, okay, this is where you're playing, but we should really write starting from this location if you want to write. But there are also other problems, like we already wrote possibly these guys to this guy. So we don't want to start before this guy. But if for some reason we end up, going too far behind or too far ahead, we want to change that, take that into account. Okay? So, first things first, let's do the get current position for the DirectSound guy. Okay, that's pretty easy. So all we have is we pass. Is that correct? Just pass a pointer to the D word. Okay. Okay, yeah. But okay. Because we call this thing from the Win32 sound buffer from our long pointer to a virtual table. Okay, and I have to like the play cursor and the right cursor. Okay. D word. Okay. Yeah. We should also pass the Win32 sound buffer. Okay. Now we have these guys. Now we should really calculate, firstly, which is not that hard, which byte we are going to write. I'm going to call that the byte to lock, because we're doing the lock operation up there, if you guys remember. And right now we're passing the 0, 1. And in fact, let's do, yeah. Instead of doing our clear, let's do our fill. So the fill sound buffer is going to be pretty much the same, but we're going to receive a byte to lock and a byte to write. Okay. Byte to lock and bytes to write. That's pretty much it. Okay. And actually, I think we can even remove. Well, no, let's not remove. Well, let's keep going. So we're going to log from this guy all the way to this guy. So this should still work. But now we need to know where we are at. So in our well, actually we should save all this stuff here in the game sound buffer. This should only be the sound buffer. This should more like the sound state. I don't know. We're gonna have a running sample index, which is like which sample are we at this moment, which is like this guy. We need to know this guy. Okay, so every time we increment a sample, I'm gonna set the sound buffer dot running sample index plus plus, and yeah. Okay, that sounds good. So the byte to lock is going to take into account the running sample index. Okay, the sound buffer running sample index. However, we need to know how many bytes, because this guy is in bytes, right? So it's the how many samples times the bytes per sample. So sound buffer byte per sample. Okay, but there's another problem, which is this guy may overflow, right? Maybe we want to start doing this guy, then we should start again. And the way we deal with overflow buffers is pretty simple. I think we did that before. We just modulo with the size, so sound buffer.size. Okay, so this is the byte to lock. That was easy. So now we can, when we go and call the fill, we update the audio, and then we call the Win32 fill sound buffer. That's the byte to lock. And bytes to write. And now we need the bytes to write. And this is a little bit tricky, because we have like an expected bytes per iteration of the loop. Okay, and which is like the last DT equivalent, right? So okay, yeah, that was easy enough. What we do want to know is actually we have an expected bytes per tick. This should be like frame because we are inside the main loop. But later on, when we take this out, we're going to change this. Right now, the expected bytes is the bytes per second, right? Okay, times our last DT. And let's do like robustness. This should be more precise because we don't want to miss frames, but maybe we're gonna do a couple of missed frames, or maybe just like a giant padding safety region for today, and maybe tomorrow when we do threading, this is gonna be better. Okay. Now, so this is the amount of bytes that we expect we're going to write. Okay. However, well, let's do like the expected byte, like let's say boundary byte. So these are the amount of bytes, but we are here in the play cursor. I mean, that's where we are playing, right? So the boundary in which we're going to write should start at the play cursor. Play cursor. Then we're going to add the expected bytes per tick. So that's going to give us the byte that we are planning to end our writing to. Okay. So that's one thing. I'm kind of reading my notes here, just because this finds kind of tricky. Okay. Now, let's find out about the right cursor, because we do have a right cursor, but maybe, let's say, maybe our right cursor is like, let's say we expect the frame boundary to be like here. We have to write at least until this guy, right? So we have a couple of things to manage in terms of the right cursor, which is actually where we are going to consider the actual writing, if that makes sense. So we're going to do like a safe write buffer, and the safe one is going to start out just being the normal one. I should really use less the autocomplete because every time it gives me wrong results. The write buffer, and if the safe write, this guy, which is the same as the write buffer, if it's less than the play cursor, which means that we wrapped. Okay, so that was the main thing. If we wrapped, we should really consider this guy as correct, right? That's the only case this should be true. So let's do like the okay. So the safe is going to be just where it is because we wrapped, right? Plus equals the whole buffer size. Yeah, because we want this guy to be in front of this guy because we're going to go and like subtract the two. Yeah. So this is like the sound buffer dot size. I think that makes sense. Now, in case we are not wrapping, all we need to do like is add a little safety. And I think I'm just going to hard code that in here. Like safety bytes. And we have like, let's do this guy. Let's do 1 frame of safety, and then maybe we can make more of 60. So in the case that we wrapped, we're going to do the whole buffer, and in the other case, all we're going to do is to add the safety bytes. Hopefully that makes a bit of sense. Just oh, save right cursor. Right cursor. Just so you guys know, this is actually like we're pretty much doing by hand, you know, from scratch, this kind of thing. In terms of yeah, we are using the library. These calculations, we could use the library to play the sound and mix the sound as well, but we're not going to do that. We're just going to use the library just like we did Windows, just to show our guy. Same thing. So we do have to calculate these guys by hand, and that's the not so fun part. But once it's done, should be easy enough. So another case that we have to worry about is that if our safe guy that we're going to try to write, if it's less than this guy, which is the one that we expect to end the write. If it's less than, which means that we are kind of good to go, right? So our target cursor, which is the one we're going to write to, can just go all the way from this guy to the amounts that we want to write. So we're going to add just like another frame from the frame that we already had. Okay, but in case we are not doing that, we probably want to do like add like a whole another sound buffer per frames. Well, let's see how this works out. So if the safe write buffer is less than the expected boundary, yeah, this means that we are pretty fast. So our target cursor, which is where we're going to actually consider to write, right? Our target cursor is going to be the expected boundary guy, right? Plus the expected bytes per tick. So that's how much we're going to write in this case. In the other case, let's just do these guys like this. Yeah. In the other case, and we could probably clean this up later on once we get to working. This is kind of what I got from the previous guy. Okay, so in the other case, in the case that we are after the boundary byte, then we should write a little bit more, and which is going to be pretty much just like the write cursor, which is where Windows wants us to write, right? Plus the expected bytes per frame plus the safety. Signed, unsigned, mismatch, safe, expected. Yeah, let's do all these guys as D word. I don't think it should be negative case. Well, yeah. Okay. So now that we do have our target cursor, we have to just make sure that it wraps around just like we did here, wrapping the sound side. Same thing here. Because since we are adding all that stuff, like we wrapped the right cursor. So far we know the right cursor is right here, and then we should wrap our target cursor as well. Okay. So the final thing we need to do is to see like if the byte we're going to lock. So let's calculate this guy, which is the whole point, right? So if the byte we're going to lock. Byte to lock, which is the first byte we're going to write. If this guy, this is the main point. If this guy is greater than the target cursor, the target is where we're going to stop writing. So if we are greater than the target cursor, it means that we are going to do like this whole thing. We're going to write like from this to this, and from this to this. Okay, so that's what we're going to compute. So the bytes to write is going to be the sound buffer size minus the byte to lock, okay, plus the target cursor. So this guy gives us this first part. This guy gives us this part. Okay, this is not that much confusing. This is a little bit more confusing, calculating the target guy. But okay, so once we managed to get the bytes to write, all we gotta do is do the target cursor minus the byte to lock. In the case where we are not behind. So if you're like, this is the byte to lock and this is the target cursor, so we're gonna do target minus the byte to lock. So that's how many bytes we're gonna write. So I believe that's about it. And just to make sure that we still have something sane in our hands, I'm gonna do the same thing again, where we're gonna do like the sign thing. I'm gonna do like samples, up samples. It's a really bad name, but same thing, like if up. Let's do like sample equals, yeah, sample if up, sample, I don't know, did we did this guy? I think we did. Might have changed that. Okay, then we're going to add that to the sample. Remember, I have to add the left and the right guy. And then we're going to do the up samples, and if the up samples are greater than, we can play around with this as well. Do like 200. So if the up samples is greater than 200, we're going to set the up samples to 0. And we should actually, yeah, no, this is correct. And then we set the up, this guy, this is just for testing. And I'm going to turn off the volume for you guys. And I'm going to debug our code. Okay. Now, let's see. You guys think this is going to work? Or you guys not think this is going to work? This is because this is a little bit confusing. So, we updated the game for the first time. Safety bytes. Oh, this is the first problem, right? Bytes. Yeah, it should be like bytes per second, not per sample. Yeah, so bytes per second. Oh, we don't have a bytes per second? I thought we did. Oh, we have samples per second. So samples per second times the bytes per sample. Let's multiply in integer first. Okay. So our safety bytes is 3,000 bytes. We're going to play around with that based on our results. We're going to play that with that even a little bit more once we get multi-threading going on. So our play cursor is 1764, and our write cursor is 7,000. Okay, that sounds reasonable. Our byte to lock, since we haven't played any sound, should should be like the first byte. Okay. The expected bytes per tick. This should be a constant. Oh. But yes, same problem. Should be this guy. Times this guy. Okay. Expected bytes per tick. Yeah, so we're gonna do 3,000 bytes this time around. So the boundary byte is going to be the 3,000. Okay, the right cursor is 350. Let's just see the new values. Oh, the precursor is 0, so I think that's even better. Okay. Nice. So in this case, the safe byte cursor is less than play cursor. No, it is not less. Then all we're going to do is going to add the safety to that. Okay? Because we do want to add safety. In this case, we should be less than, yeah. Oh, we're not. We're not less than the expected boundary bytes. So we're going to be the right cursor plus the expected bytes plus the safety. 9,000. Okay, so we're going to write now 9,000 samples. Let's see how much is that. 44. This is like, yeah. That's seconds? Yeah, that's seconds. Maybe that's a bit too much. I have to play around with that. With like the safety margin, guys. Okay, now in this case, the byte to lock is not greater than, then all I have to do is subtract this guy. So I should write, yeah, the 9,000 bytes. Now let's update the game audio. So we have the samples, which are going to be overrun every time. The samples are just for our convenience, because we could write directly to theirs, to their buffer and not have to copy, but we don't have to worry about the ring aspect of the sound buffer. Okay, and samples right. Okay, we didn't set samples right. We have to set it here. So we do the sound buffer dot samples to write equals bytes to write divided by bytes per sample. And let's just see if this number will make sense. So we should write 9,000 bytes. Oh, we did the math wrong. That's in bytes. So we may actually be, yeah, okay, 4 bytes per sample. So we're going to, oh, that's a better number. So we're going to write 2,000 bytes, 2,000 samples. So 2,000 and let's say 200 samples divided by this guy. Okay, this is better. So consider our frame is .016. Writing this guy is kind of reasonable. And yeah, we're gonna play around with the safety, but this one's kind of reasonable, I think. Yeah. Let's just see if this guy divided divisible by 4? Should be. Yeah. Okay. We should also assert that just as a note. This guy should always be should have no mod for result. Okay. Okay. Yeah. Well, crashed, but I didn't expect. What? Is this guy not divisible by 4? This is not. That's weird. We're trying to write that many bytes, but can't. Because that's not aligned? Why is it not aligned? Oh. No, this is wrong. No, this is right. The bytes to write divided by the bytes per sample. It's going to give us the samples to write. Yeah. Yeah, you know what? Bytes to write. Well, let's go back and see if we managed to crash here. Well, should have not stopped the game at that point. Maybe that was because of our breakpoint. I don't know. Well, when you crash, you're gonna have to fix that. Now let's go inside here. So we are supposed to write. Yeah, this is way better. Yeah, we're like 1900 samples, which is like, it's pretty much the same thing. Okay, and let's hope this is correct. Okay, now I'm gonna try listening to this guy here, and let's hope I don't die. Okay, now we crashed. Let's see why we crashed. The bytes to write. It's not a multiple of 4. Let's just make sure that's the case. No, it is not. Because the size should be a multiple. Calculator. And it is. The byte to lock is 0 and the target cursor. So the target cursor probably isn't. The target cursor isn't because, well, let's see if the right cursor should be. And it is. The expected bytes per tick probably isn't. Yeah, it isn't. And the safety bytes isn't also. So yeah, I should probably align these guys later on. So, maybe we can just do like, first of all, we multiply this guy by this guy. Well, actually, should make a difference. Okay. Let's do like the ugly thing, like do safety bytes plus equals safety bytes modulo, let's see, this guy, bytes percent. Yeah. One frame of safety. We're gonna clean that up later on, and also this guy. But for now, let's also safety bytes. Let's also change that to the expected bytes per tick. Okay, now that shouldn't happen, and let's try to hear that. Okay, we're hearing nothing. I'm just going to make sure that I can hear something, because sometimes these speakers go to like sleep mode or something. So I'm gonna put this song. Yeah, they were in sleep mode. Okay, now they're not in sleep mode anymore. Let's see. Yeah, can't hear anything. Oh, okay. Well, we can't hear anything because our fill sound buffer doesn't do anything. I think. Yeah, it doesn't. Okay, that's kind of stupid. What we're gonna do now, we have the at, and now we're gonna do like the, well, let's call that dest, and this is like the source. The source is gonna be the sound buffer dot samples. Okay, and this is like source plus plus. This is the test. Okay, and just to be extra confident that this is gonna work, I'm going to put a breakpoint here. Like here. Well, isn't that very nice? We're not calling the fill sound buffer, or did this call fail? Yeah, the call failed. Why did the call fail? And you know what? We should probably, in these succeeded guys, probably make like a valid code path like this. Succeeded. Like, yeah, on these two guys. Yeah, just so we are extra safe. Yeah, this one. So we should crash now. Okay. And well, let's see. These look pretty reasonable, I think. Pretty reasonable. Oh, okay, yeah. So we crashed because we forgot to unlock the buffer. So the buffer is already locked. Oh, thank God I remembered that. It would have been a pain to debug that. We're gonna have to get the last error, and it'd probably be a weird error. So unlock. Let's do DirectSound. Unlock. Okay. Yeah. Unlock. Okay. Unlock. And we just pass. Well. Yeah. Succeeded. In 32 sound buffer. Long branch of virtual table. Unlock. Then we pass region 1, region 1 size, region 2 with extra cheese, and and that should be good. Function through point. Yeah, I always forget. That's only in the C version of DirectSound that have to pass this guy and do like the virtual table thing. C++ you don't. Now let's see, and that was it. But I have to do that on both calls, or this is not going to work. Okay, I think I'm going to do that if we succeeded the lock, but we should succeed the lock anyways. So yeah. Okay. Now let's see. Okay, so now we're gonna lock, yeah, all the guys in the first region because that's the first writing we're doing, and our source. Let's read our source. Looks pretty reasonable. That's what I meant. I'm going to do the sample counts, the running sample index. I don't know. And now, if we do get the correct sign, we shouldn't hear that looping problem that we heard. So let's try to hear that. Okay. So we do have a sign, but we are asserting at this point. So at some point, we couldn't get the lock. Passing 0 bytes to write? Why are we passing 0 bytes to write? Like, let's do an assert bytes to write. Or maybe if it's just 0, we just ignore it. I don't know. Yeah. Well, if we're not going to write any bytes, sure, let's not do anything. So we got a super ugly noise. Very ugly noise. So this is probably very wrong. Now, let's see if we understand the way we think we understand. And in the audio, if we set this guy to 0, we expect just to hear that ugly noise on one speaker. Okay, that's correct. So I only heard that on the right speaker. And let's do that and that. So you guys, I don't know if you guys could see the difference. So this is working. Okay, what else couldn't be working? Maybe our running sample index is wrong. Yeah, this is gonna. I think this is gonna be kind of hard to debug. So this is working like we expected. Just to be extra sure and discard that, let's see what our sound buffer says. Yeah, let's see. 1911 sounds. Okay, I meant actually like this guy. Well, let's do sound buffer samples. Let's see, 1911 samples. So we should just see them. Yeah, this is pretty reasonable. Yeah. Now in the fill guy, this should be correct. Let's see if this is correct. Well, I don't know why I couldn't. Okay. Now, yeah. Let's see the region 1 samples. Region 1 as a pointer to an S16. Yeah, so we are copying nicely. Yeah. So the problem really is this code. And I think I'm going to quickly see if there's anything really wrong. We ran through that a couple times, and then I'm going to compare that with the other code, just because this is a little bit tricky. So the safety bytes. Well, let's try increasing the safety bytes. Maybe you are missing a frame rate. Oh, nice. So that was the problem. Huh. Didn't need to debug that. But for some reason, our guy is still not aligned. See, our byte lock, is it greater than this guy? No. Oh, I'm sorry. No, it is not greater. So our target cursor, let's see if this guy's a multiple. And maybe I'm just stretching and we shouldn't care about it if it's not a multiple of 4. Yeah, it's not a multiple of 4. The target cursor should probably be the same problem. Except this guy should not be a multiple of 4. 618. Oh my god. Okay, 618 divided by 4. Our expected bytes per tick is not. Shouldn't this work? I mean, maybe you should do like 4 minus this guy. Yeah. Okay, so this was wrong. It should be. Yeah. Okay. It's still pretty bad. It's really, really bad. Let's do like more of those. Probably also do an optimized build. Let's do an optimized build just to see. But if we, I know I don't like that. Okay, nothing changes. So I think I'm just going to check out the other code. Just go through it and see if there's anything really wrong. So we try to get the play cursor, and then we create a byte to lock, which is like the sample index times the bytes per sample, and we do that the buffer size. Okay. Okay. The bytes per tick. This guy has 2 of those, but it's just the same thing. Is the samples per second times the bytes per sample. Oh, divided by the refresh rate. Let's say if it's 1 over 60. Let's try to hard code that. Instead of doing like the DT. Let's try doing that. And so that fixed it. What is our frame rate? Let's see now that we do have that a way to show it. Current time. Let's do a print f32 last DT. Yeah, it's really, really fast, our frame rate right now. So I'm not going to complain about that. And we are going to do the audio fixed frame. So this part of the code, which apparently is where the problem was. Let's do the audio. This part of the code is where we're going to not do it like this. We're going to do like a fixed, and then I'm going to sleep here. It's going to be better. But I think sounds like a nice loop. I'm going to put it for you guys to hear. Is that reasonable? I don't know. Yeah. Okay. Now that this is apparently working, all we have to do is now, instead of doing, okay, so apparently we are done for the library use, okay, which is awesome. Now it's all up to us. Instead of doing like this, I'm gonna do like position, and we're going to get the test sound dot samples at position. Plus 1. Then we do position plus equals to 2. Let's see. It may be some other thing, but I can hear a faint jump. I'm gonna try to put my headsets on to see if I can hear that jump as you did. Because, well, to be honest, this is a square wave, which is not a very nice wave. So you probably should hear like a strange square wave pattern, so it shouldn't be like a sine wave, which is perfect. So maybe that's what you're hearing. But okay, so we crash, but that's no biggie, just because the, like, if position is greater than test sound dot sample count, position equals 0. Yeah, in fact, I'm gonna go back and listen to listen to this guy, just so we can check out together if there is a faint jump. I don't know, man. That looks a perfect square wave to me, which is that doesn't look like a square wave. That sounds like a square wave, I should say. Okay, let's go back, and now we should listen to our music, which we managed to implement already. Let's do this. It also loops perfectly. So now it's really where the fun begins. So, like, do our mixer. Now we're going to start implementing our mixer. Oh, that was cool. We managed to get that out of the way, and now we're going to implement our mixer guy. And basically now we can play a lot of sounds together. Maybe we can sync sounds and pan the audio, all crazy stuff like that. That's going to be fun. I'm going to quickly go to the bathroom and like do a quick 2-minute break. When I come back, we're going to go all crazy now with this system that we spent like 2 hours to create. Like, this basic system of playing audio files should be what we need to go all in our mixer, which is going to be awesome. Okay? 2 minutes. Okay. I think that was less than 2 minutes, which is even better. So let's start doing our mixer. First thing we're going to do for our mixer is to separate the idea of a loaded sound and a playing sound. Because if you load like a, I don't know, block destroyed sound. We want to be able to play that multiple times, maybe one on top of the other, without having to load that sound multiple times. So what I'm going to do is to do a playing sound. And this guy, first of all, is going to have a pointer to a loaded sound and a position. It may be like a looping. Then we're going to have like a pan and a volume. I'm going to add a lot of stuff here. For now, let's just add these two guys. Okay? And then we're going to have like a playing sounds array on the stack. Let's say we have like 32 sounds max at the same time. And then this like the next playing sound. Okay, and now we're going to do like an internal playing sound, play sound. Then we should take a pointer to a loaded sound. Like sound. Maybe that's it for now. So, playing sound result is going to be equal to the playing sounds plus the next sound to play, next playing sound. And if the next playing sound is greater to or equal to the array count of playing sounds, then I'm going to turn my mic down a little bit. I think maybe clipping just a touch. Okay. And if the guy is greater than the array, I'm going to reset him. So okay, now the result dot sound is going to be, I think I'm just going to, yeah, I don't know. Result dot sound will be the sound. Result dot position is going to be 0. Result dot looping going to be, I'm going to pass that as a parameter. Yeah. Okay. Playing sound. Playing sounds. Result. Arrow. The old arrow versus pointer thing. Return result. Nice. Okay, now at this point, for every sample, we're going to go like, let's call that sound equals playing sounds. And then if sound, oh, let's just remove this guy. And if sound is different than the playing sounds, plus the array count playing sounds, sound plus plus. We should also have like an active flag. Okay, so if the sound's not active, continue. Okay. Now, if the sound is active, we basically want to do like a left sample and a right sample. Okay, so left sample and a right sample. And these guys are going to do like the left sample plus equals, that's the basic mixing thing. The sound samples at the position plus plus right at the, yeah, I have to do like sound position. Okay, now if the sound position is greater or equal than the sound sample count, okay, either we should loop. In this case, I set the position back to 0, or or we shouldn't loop. In this case, I just set the active to false. So sound active equals false. And you know what? This is kind of wrong. I should really, yeah. This is wrong because let's say in the beginning of the game, we go through and play like, I don't know, 5 tracks. Yeah, so this is what we're going to do. I'm going to get the next playing sound. And if it's a looping sound, I don't know. Let's do like a I could do a free list for the sounds. Well, we shouldn't actually ever hit 32 sounds. And you know what? You know what I think? Yeah. Instead of doing this, I should really just not play the next playing sound. If we have more than 32 active playing sounds. Yeah, but I still need to yeah, maybe this is kind of ugly. I'm going to hard code a let's say safe sounds. Let's say I don't know. Let's say 10 of them are safe. Safe sounds are the first. Well, I don't know. I think you guys understand the problem, right? Problem is, if we play a music, but we have like at some moment a lot of craziness going on, we shouldn't actually stop. We shouldn't actually get the music and go back. So you know what? Maybe I'm just going to loop through all the inactive sounds, or the active sounds that don't have. Yeah. Good evening, Bearded 3D. We are implementing sound to our game, and we managed to do that quite successfully even. Let me show you guys. Okay, yeah, we just broke the sound. But we're going to make a better mixer. And I don't think I'm going to care about this for now, and maybe I should assert and do like incomplete, do something better about this. Yeah. Okay. So now we go through all the play sounds. Yeah, this looks perfect, I think. Now, in the game, when we load the sound, now I should actually play the sound. And I'm going to set the looping to true in this case. Play sound undefined. Okay. Yeah, this kind of sucks. Well, no, I think I can just make the game after the audio. I don't think the audio uses the game. Yeah, it doesn't. Test sound. Yeah, well, it does use the test sound. Well, not sure this is a good solution. Test sound. But let's just get the test sound here. Okay. Now, I'm gonna keep my earphones on, and I'm gonna keep audio for you guys as well, because now we shouldn't have like weird sounds. We should have nice sounds going on. Give you guys a little bit of sound. Oh, I don't hear anything. Let's go to play sound. Well, loads. Yeah, well, we did call play sound. Well, let's see. Yeah, well, kind of hard to debug if we are optimized. Okay, so we load this guy and we set the play sound. Yeah, the result is 0. Oh, okay, I found a problem, but not the problem. Forgot to increment the next play sound. But let's see. Now the result sound is this guy, looking good. And the result position 0, looping is true. Oh, yeah, we added the active system, but didn't set this guy to be active. Okay. Result. Let's see. That's here, actually. Okay. Yeah. And this song is not actually this game song. That was my other game song, which you guys can check out on itch.io. It was this song. I think I'm gonna make a nicer one for this game. I'm getting better at it as well. So now what we should be able to do is play more than one sound. Let me just copy from the other directory. Hello, man. How are you doing? How are you doing? We're adding sound. Let me just keep the sound going on while I get the other music, because that was a nice victory for today. And we're not done yet. Still gonna do a lot of cool audio things like panning and changing the pitch, things like that. So data, well, let's go to music. There's a nice melody one. Yeah, I like this one. So let's go back to the breakout data. Let's do test. Okay, breakout. Yeah, I think this game is getting really cool. We started out as a breakout clone, pretty much. Like this. Probably saw that 1,000 times. Can you guys hear me with the turn the desktop audio? Yeah. So you guys probably saw that 1,000 times, right? This breakout kind of game. And then we added like some cool power-ups on this level. So let me see if you can get it. Yeah. Dude, with audio, this game's gonna be so much nicer. Yeah, so that was like the invincibility power-up. That's like 3-shot power-up. Yeah. So I don't know if you guys could hear that. We missed our frame rate for a frame because of the particles, since this is not the optimized build. And the audio glitched just for a quick second. That's what we're going to avoid in next stream when we do like multi-threading for the audio system. Oh, nice. Yeah. So, but this is the cool thing in the game, in my opinion. We have like breakout pawn. So we kind of well, the position is not perfect. I think. Yeah. So it's kind of hard or impossible to get the ball behind him. I have to debug that later on. Okay, and then we have breakout space invaders. This one's pretty cool. Yeah, especially when we get like the power-ups. Yeah, look at that. Awesome or what? And the idea for the game is to make like a lot of old arcade games as if all of them were Breakout. So we're gonna do like Breakout Tetris, Breakout Donkey Kong, Breakout, I don't know, whichever ones we can think of and kind of decently implement, we're gonna do them. Yeah, I'm really excited to add sound effects. Sound effects are gonna be really cool. Maybe gonna do that today. Okay, let's try implementing now the test audio test sound 2. What are you using for the graphics? We built this entire engine and game from scratch. So we're not using anything for the graphics other than what we wrote ourselves. So no OpenGL, no DirectX, no Vulkan. This is our rendering thing. So we wrote everything ourselves. So yeah, we convert that to pixels and we fill the pixel. We learned the colors for the alpha blending. We do like rotated. Yeah, we did bitmaps last stream. Those were awesome. Last stream was awesome. And then we did rotated rectangles before that. So the particles can be rotated. We did like some matrix multiplication, thing like that. That was a little bit tricky. So if you want to check out the whole process, everything is on YouTube. You can go to youtube.com/danzaydan. And you can see the making a game in C from scratch. It's literally from scratch. We started out with like a blank file and nothing. No libraries, no nothing. Well, we did use a library for the PNG guys, so, but we could not use PNG. But we're not going to use PNG in the long run. Well, we're kind of getting there really quickly. So you can see the whole process from every stream all the way to this episode. So this episode right now is episode 11. So we did the math last time. I think we did like 30, 28 hours of programming, 30 hours of streaming. So in 30 hours, we're doing this from scratch. And we did all, you see, so the bitmaps was the last thing we did. Now it's audio, right? But we did like particle systems and all sorts of crazy stuff for the game. And we're finishing an engine pass in which we're creating like audio and multi-threading, things like that. And when we finish that engine pass, we're going to go back to the gameplay and add all the games that we want to add, like Tetris and Donkey Kong, maybe Super Mario. I don't know. You guys can have a lot of ideas as well. Damn, I couldn't do that myself. I love my library as well. If you love them, that's cool. But it's also nice to learn about how they work. So maybe you'll love them even more, or maybe stop loving them. I don't know. Yeah, it's pretty cool. I have to play the game sometimes because it reminds me. Oh, and it's also open source. You can go to itch.io and download the game source code for free through the whole process. So you can go all the way from the first day, which we did like basic rendering, all the way passing through the particle systems and all this stuff, the gameplay, all the way to last time around. Cool, so let's test if we can play 2 sounds at once. Test sound 2, and then we add audio test sound 2. I don't like having to do this guy here. Oh, actually, we don't need to do this guy here. I don't know why it complained about this. Yeah, I don't think we need it. Let's see, test sound and test sound 2. Oh, this is wrong. This is like old stuff. Yeah, I forgot to delete. That's why I was complaining. Now I have a pretty nice structure for the game. I'm working on a 3D engine, so I couldn't do stuff from scratch. It would be hell without. Yeah. Yeah, well, if it's a 3D engine, that's a lot more complicated. And both in terms of performance, because this is a very simple game, graphics-wise, we can do that on the. Dude, that already worked. Can you guys hear like the other music playing, like that melody? That was awesome. Yeah, so 3D games are a different kind of beast. I wouldn't do them without doing OpenGL at least. But yeah, this one's fun to learn what goes on under the hood there. Awesome. So we are playing multiple sounds. So let's go back to our list, do our mixer. So play several audio files. Now let's do panning. Panning should be really easy if you guys can see what I'm doing, right? Because we have, like, let's do pan, which goes from 1, it goes from 0 to -1. So pan goes from 0 to -1. And then here, all we need to do, yeah, from the left sample, is to multiply this guy by the sound pan. Well, the left sound, if it's -1, should be 100% on the left. You know what? I'm an environment tech artist, so I actually have no idea what's happening. A programmer, I have no idea what's happening. They're not alone. It's cool though. Thanks. Yeah. Yeah, we've been doing that for a few hours, so it's kind of hard to get the train going on. But I think if you go to the very first stream, I think you'll be able to follow along pretty nicely. Well, if that's your thing, if you want to learn more about doing things from scratch, even if it's a simple game. But thanks. Just glad to see you guys think this is cool. So I'm gonna do like a separated like left sound sample, and this is the left sound sample. I'm gonna do the same thing for the right. Then I'm gonna play around with the panning stuff. So the thing is, the left sound sample should be on the left channel if the panning. So let's do like 32, 16. The panning, if panning is 0, if the panning is -1, should be 1. So it's going to be like. Actually, watch the first stream. Dude, that's awesome. It's nice to see that you watch the first stream. Yeah, definitely. Because I'm coming late. Hard to understand that goes for in programming stream. Yeah, that is true. Although today we did like another system from scratch. We started audio from scratch today. So if you haven't watched the previous streams, today was a pretty from scratch stream. As was yesterday, I think. Did bitmaps. We did a lot of stuff yesterday. Yesterday was crazy. Yeah. Okay. So this is the math part that I'm not too familiar with. Our pen goes from -1 to 1. Okay, that's this variable right here. We are multiplying that by the left sample. So we want, if it's -1 or 1, we want that to be 1. So all I'm going to do is add 2. I'm going to invert that. It's going to be 1 minus -1. Yeah. So it should be 1 minus 0. Seems like it should have a lot more views. Just C Sharp. Yeah, I mean, I just started that like 2 weeks ago, and I did like no streaming beforehand, before that. So maybe the views will come in time. Yeah, and this is just pure C. Maybe next projects I'll do C++. I think people like that more because that's the industry standard. But since this is just a small game for fun, C is more fun, I think. So I think that works. So 1 minus minus 1 is 1 plus 1, so it's 2. So we should probably clamp that. 0 minus 1. And if you are 0, 1 minus 0 is still 0. Okay, so that looks correct. And for the right channel, let's change that to right. Sweet, no more questions from me. I'll just enjoy the stream. Dude, if you want to ask questions, that's okay. That's cool. Yeah, I'm learning C in school, but I hate to say that I like C++, so I almost failed the course because I didn't want to learn C. Yeah, I mean, if you do all sorts of crazy stuff with C++ language features, you're going to miss that in C a lot. But that's not my thing. When I use C++, I use like not too much crazy features. Although I do miss like default arguments. That's the main feature that I wish C had, default arguments. Because there's a play sound thing. It's gonna get crazy. We're gonna pass the pan here. Well, see, that's the thing. I don't want to pass the pan here. I think I'm not going to pass the pan here, and I'm going to let the guy receive the sound and then change the pan. Because see, otherwise this guy's going to take like 1,000 arguments. That's no good. So sound pan plus 1 clamped from 0 to 1. I've seen C dev. I have no idea. What do you mean? C is pretty much like C++, except it's easier to read, in my opinion. It's easier to see what's going on in terms of like the code, because there are not that many features. So yeah, I mean, if you know C++, you should be able to do something in C. I mean, yeah, of course you do like all sorts of crazy stuff with the std libraries. Then you should, I mean, if you use like std factor for everything, like things like that, then you can't do that in C. You should be able to do your own thing, like S16 or the internal void. Yeah, I have no idea what those three are. So I did, in the beginning of the stream, I typed F some types. So S16 is a signed 16-bit integer. So that's just easier to type than like long. That's short, actually, yeah. To be able to do that with short. So that's what this guy is. And the this guy, well, is a pointer to an S16. So doing this means like doing this guy, which I'm assigning this guy to the variable where is pointing at, and then I'm incrementing the value of at. So yeah, so that's more like pointer craziness. Puzzle dev. What I like about C is that it's so simple compared to most noisies. Exactly, that's the thing. Well, let me go back. C is not. Well, you can get some pretty complicated things in C, but puzzle dev is right. I think it's simple. I mean, there are fewer elements that you can play around with, and the cool thing about C is that what you build using those simple elements are what makes the program interesting. Not exactly like doing other kinds of crazy stuff. Although people sometimes do with meta programming, crazy stuff in C. I have done some crazy stuff, but like weird, really crazy stuff. But yeah, for this game, since it's a smaller game, I'm going to do one step at a time. Maybe next day I'm going to do C++. Not sure. So let's see if we still have the same thing. We do. Sounds perfect. Now, what I should be able to do in the game, I should do like playing sound S. I should be able to do S pan. Let's do it -1. Let's see if we only can hear that on the left ear. And we only hear that on the left ear. That's awesome. And let's do that on the right ear. See, that's the cool thing about writing things from scratch, or at least having a good understanding of how things work, even if I were using like a full mixer library, is that it makes things easier to expand and understand and do things like that. That was pretty cool. So we did the pan. Actually, I have an uncertainty about the pan. Should I also add to the left channel the right channel panned? Like if I pan all the way to -1, should I just exclude the left channel like I'm doing now? Or should I include that on the other ear? I'm not sure. And just for fun, when we do like player P, let's see where we have player desired P. Let's do like this guy. To divide it by 4. S. Yeah, that's just for fun. I'm gonna do like proper sound later on, but that's just to get started. Declaration of S. Oh. Let's do like Isn't that really, really cool? And actually, we should do like a listener kind of thing for the audio system. Like, make the player the bass listener, so everything from the left of him. Yeah, I can do that later on. So, yeah, I think I'm gonna do. I'm gonna add the other guys in the pan as well. So the left sample is gonna be this guy, which is the left sound, the left ear, right, clamped by this guy, and then I'm going to do the right one, also clamped by this guy. So, let me think about this for a second. If it's 0, we should have left and right. If it's 1, we should have nothing, left and right. Yeah, so I'm gonna have to add something else here. And we should probably optimize this later on. This is like really crazy. So, let's see. So we go from 0 to 1, we take the left, so no need to do this here. Just clamp. And then we take the right. Oh, I'm doing the other way around. This should be here. So I'm taking the left and adding from 0 to 1. Okay. And this guy should be -1. Yeah. 0. Okay. Let's see. Yeah, that's better. If that's not super, super cool, I don't know what is. I don't know what it is. So we can now pan the audio. Let's change the pitch for the audio, and we could also like implement sound effect, like make the player P the listener to do panning. Okay, let's change the pitch. And the idea of the pitch is really simple. So how is the pitch controlled? Well, if you have like a big wave, that's a very bassy kind of sound. And if you have like a very frequent wave, that's a high-pitched sound. So if you have this wave and we want to make it higher pitch, and imagine we have like these samples. I'm going to do like the poor man's version. Then we can do like a better version first. Okay, so don't go like too crazy on me. So what I'm going to do is just skip every other guy. And so we're going to do like this guy. And then we're going to do this guy. Then we're going to do this guy. We're going to do this guy. Instead of doing like this, we should be able to do it like this. And this is not like, this is bad for a couple of reasons. First reason is that we're going to compress the sound's length. So we're going to speed up the sound. So that's one problem. But no one cares, because we're not going to do that for the music. That'll be for like small sound effects, for variation. And a pretty cool sound effect that I think we're going to add. It's going to be awesome. Okay, so that's the first thing, the first problem. The second problem is we should actually lerp between these guys to generate new points. I don't think we're going to do that just because it'll sound okay for this kind of game. But if you want to expand that, maybe you can lerp. So the basic idea is, instead of just getting the sound sample like this, sound position, ++, I'm going to make the sound position a F32. And I'm going to add to the position, let's say, let's do like sample. It's going to be sound position. So nothing should have changed, right? So we're going to do sound position plus equals 2 times sound. Let's call that speed multiplier. Okay, so we're going to add the speed multiplier. And here, speed multiplier is going to be 1 to start with. Okay, maybe we should clamp that, but I don't know. So instead of changing the pan, let's change the speed multiplier. And I'm just going to play one sound, because since I'm going to also change the speed of the sound and the pitch, this is probably going to sound weird because it's going to overlap the other sound. Now, okay, so we get nothing. Let's see if this was a problem. And in fact, this, instead of setting to 0, now that we have a floating point, we should just do it like this, because we can have a little fraction. Okay. Yeah. So okay, this is back to normal. Now, why couldn't I multiply that by the sound speed multiplier? It should be 1. Oh, it's not 1. It's 0. Yeah, because we set that to 0 here. So I think I'm gonna do like, I'm going from approximately -1 to 1. Then I add 2. So now I go from 0 to 2. now I'm going to go from 1 to 2. No, I'm sorry. Let's do this a little bit calm. I'm going from -1 to 1. If I add 2, I'm going to go from 1 to 3. Yeah. I'm gonna add 1. So I go from 0 to 2. Then I'm gonna add half. Yeah, so add 1.5. Should be okay. So I should go from like half. Yeah, I don't know. Let's see. Yeah, that wasn't the most pleasant thing ever. If I add 1, let's see. Well, let's just set that to like 1/25. Yeah, that sounds pretty bad. I think we're gonna have to do the lerp. Let's try getting a sine wave, and that's one of the main uses I do for, actually pretty much the only use I do for this kind of effect. I have a sine wave. Let me throw that on the breakout folder. I have a sine dot WAV. Okay, and let me show you guys what it sounds like. Oh, it's just a sine wave. And it's not looping properly. So I have to fix that. If I do this guy like 0, let's see if it will loop properly. Nah. Let's go back to the position as a int. And then a sample, just put the position. Then so we have another bug. Unless the sound is messed up. Yeah. So you should probably fix that before trying to add new features. But the basic idea is I want to be able to do something like this. Well, let's try to do this. Yeah, this guy sounded okay, I guess. Well, actually didn't do anything. Yeah, well, 2 times this guy converted by int is going to be the same thing. Unless you go faster. Let's try going faster. So for the sine wave, it works pretty nicely. Yeah, well, I suppose it does, because this is a crazy hack we're doing. But if the wave's like this and we have enough samples, which we pretty much do, then we do like from this guy to this guy, from this guy to this guy, it's acceptable. Let's try to like 1.5. Yeah. Let's try. Yeah, so the 0.5 thing doesn't work. Let me just get a reference, because I think I did the same thing in the other game and it worked. So position. Yeah, well, just yeah, we do that differently. We just add this guy. We just add a sound multiplier. And then when we get the sample, yeah. And when we get the sample here, we do like left sample is the position. Yeah, so the position, yeah, I should probably note that. The position now is not going to be, it's going to be per sample. Yeah, sample position. Which that explains, I think. Oh, I think that's going to explain a lot of things. Yeah. So what we're, okay, we have a pretty weird bug. The bug we have now, in fact, well, yeah. The bug we have now is that since the position is being added twice per sample, because it's going like per channel, we actually are only playing half of the sound. And we didn't notice that when we looped the music, because the music is like 8 bars, and they are pretty much repeated. So so when we played half of the music, it also looped. That's why we didn't hear it, but the sign didn't. That's why we heard the sign problem. So I think this should work right off the bat just by making the position an F32 and adding like 1 position per sample. But now this guy has to be a little bit different. So this guy is going to be the sound position for the left, right? Yeah, and this guy's going to be +1. And I did this like channel count thing, but it really doesn't matter. So I'm going to just do a cast to int in this case. So that was a funny bug. I know I did find it a bit weird. I thought we didn't play the whole sound, but I thought, okay, maybe I didn't export the whole sound. But no, I was wrong. In fact, let's do the sample thing here. So this would be the sample, and this would be sample +1. No, I don't think this is entirely correct. Like, yeah, I do have to multiply that by the channel count. Yeah. Yeah, okay. So I think that's going to solve a couple problems. Let's see. So that solved the loop problem pretty much perfectly. And if I go back to the game and play both sounds and go back to the test sound, test 2, yeah, test 2. And then we do play, we do like S, this guy. Notice that the music is a little bit longer. There you have it. Perfect. Perfect. Now let's try messing around with the music. So again, nice. Yeah, this is not the best pitch shifter, but it's not bad for this game, at least. I'll try playing them both and go crazy. Okay, now we can start having some fun. Okay? Can I start having some fun now? Well, I've been having fun because today's been a great day. But I'm going to start having more fun. So I have like the sound guy. Let's see, yeah, playing sound. Remove this guy, and then we do like loaded sounds. Let's do music, and let's do sign. Okay, so music is gonna be this guy, and we're gonna do like music for next time, and then play music. And now I'm going to add a player struct. Well, let's do like player movement movement sound, and I'm going to add that the sine wave sine sound. Let's do sound sine. Yeah. Okay. Now, player movement sound. We don't have such a thing as a player movement sound. So let's add a player. Have like player desire key. Oh, let's go. Where's the player? Okay. Oh, shows the player. I don't know. Player stuff. Player stuff. Gonna add a playing sound. Also, we don't have playing sounds here, so I'm gonna do is playing sound. Player movement sound. And this guy, well, I don't remember which order we chose. Let's do like the playing sound. Okay, and okay, so we didn't load. Probably load. Yeah. Sound sign. Open this sign. Let's remove. Yeah. So we got an invalid sample. So because the sound count is 441, which is like 1 second, and we sampled to 45. Okay, because this is wrong now. If the position times the sound channel count is greater than sound channel count. Okay. No, it's still not right. No, this was right, but for some reason, I don't know. Yeah, I'm pretty sure we should have stopped here. Let's see. Yeah, we fetch that. Let's do like this guy times 2, just to see. Yeah. Sound sample position. So this is correct. Oh, okay. Well, no, I thought I had a problem. I don't know what the problem is. Let's see, we are trying to fetch the samples at this sample. If we have these now, oh, we are mono. Okay. So let's support mono. So we can't do this. Have to do like plus sound channel count -1. Yeah. And this guy is 2. Yeah, and this also should be like channel count. Okay, this sounds okay, and this sounds okay. Yeah. Okay. Now, hear that sound. And let's make that sound awesome. Okay? Step 1. That sound will only be, oh, we don't have a volume. Let's first do a volume. So first step in doing that sound awesome, let's expand our let's clean this up. So let's take 2 steps back. Let's implement the volume and let's make this guy. Because maybe I should make all these guys as a float, I think. So convert these guys to float. And then it's already float. It's already float. It's already float. It's already float. And probably gonna do the addition in float as well. So yeah, I can remove this parentheses here and this guy here and this parentheses here. Okay. Okay. So probably didn't change anything. Let's see. No, we didn't. Now we should be able to do times sound volume. And let's just see if we can optimize this some way. We're multiplying the left sample. Yeah, each one of these guys is unique. Oh, but the sound pan. Yeah, we could not make the clamp every sample. Let's try to do that. So, oh, but we are inside every sample. Okay, well, let's not worry about that. Okay, now the let's see, volume. The default volume should be 1. Let's see if we are back to normal. Okay, so first step, make our audio mixer engine support what we want to do. Second step, in our player desired, let's see, desired, oh, in the game, player desired P, when we set the target P, finally, when we start rendering the player, actually we could do that. Let's do it here. Let's do it here at the end. We're going to do the player movement sound volume. So we only want volume. if the player DP has stuff. Now, this can get loud, so I'm going to multiply that by this guy. And let's try move pretty slow. Okay, so this is gonna be good. I think you guys got the idea, but this is pretty wrong for some reason. If this guy, if this value is not smoothed, which maybe it isn't, maybe we have to smooth the volume by hand. Let's make it a little bit less intense. And let's just try and set the volume to like half, just to see if it works. Yeah, it works. But the problem is this guy. Let's print this guy. Yeah, it's really all over the place. Ouch! Sorry if that was too loud for you guys. That was too loud for me as well. So we should probably clamp this guy. Let's clamp him like, I don't know, 3. Clamp F. So yeah, some functions. And we should really get the absolute of this guy. What if we get this, the player, have the player visual DP? Let's try that. I think I'm gonna have to add my own thing for the, because the DP is so unpredictable, because the mouse goes all over the place. Do you have other player DP stuff? See, target DP, half size, visual DP. Yeah. So I'm gonna add the player movement sound volume. Yeah. D. So yeah, it kind of sucks. So I'm gonna do like a player movement sound volume DD and do the same same smoothing thing we did. Well, it should be an easier smoothing function, because I've been doing like the just before we actually commit to doing that, let's just see why the visual P is so weird. The visual P shouldn't be that weird. It's decreasing quite nicely. Oh, then here it increases dramatically. Yeah. Yeah. Oh, okay, because we actually shouldn't set the DP directly to the volume. We should make like a volume plus, yeah. Okay, so let's clamp that, like let's do -1 and 1. Yeah, so I'm going to add the clamped volume times the target DT, which is just DT. Yeah, this is more work than I thought. Okay. Now, this should be 0 first. Well, let me print this guy. Now I really want to set that to this guy. Yeah, that's what I wanted to do really. So it starts out 0 and let's say goes all the way to 3. Ah man. Yeah, let's do the other variable thing. Okay, so I'm going to do the player movement sound D, which is the delta, right? I'm going to do the DD. So I'm accelerating towards this guy, and I can play around with the values later. And then my velocity is this guy. I'm also going to add like friction force for the sound. I don't know, this is kind of hacky. Times dt. Yeah, not sure. And the player, well, this final guy here is going to be the clamp version of. Let's do himself, player movement sound volume, plus player movement sound volume, yeah, d times dt, plus the dd times dt squared times half. Yes, player movement sound volume. Now convert from int. Okay. Oh. Wow. Okay. Okay, now let's see what we have. So we have a positive acceleration, yeah. But now let's tend That's 10. Now this guy to 0. So I'm gonna add a acceleration. That's gonna be, let's say, 40 times minus the velocity, which is, I want the velocity to go to 0, basically what I'm saying here. Well, the velocity, yeah, well, let's say the velocity to 0. No, actually it shouldn't be the, this guy. Yeah. But I'm gonna add like a lot. And we're gonna start out with 0 as well. Okay. Yeah. What's gonna be the visual VP? Let's say the absolute that times 1,000. Maybe that was a bit too much. Okay. I'm just going to start that play sound. I'm gonna set this guy volume. It's kind of getting annoying. This guy's too much. This guy's too much as well. Yeah, this guy was too much. Okay, starting to be nice. Let's see. It's not a very pure sound. Think I may have to think about that for a while. Because now we're doing is every time we move, we want to go faster, but we also want to decrease the sound. Let's see in our print what we had. See, this jump is a very bad jump. So maybe, maybe I don't know, if I clamp this guy, yeah. Oh, let me see that again. Yeah, because we do have some pretty crazy spikes. Let's change to the target DP. I don't think that'll make much difference. It is a bit better, but it's not 100%. So you know what? I'm just gonna do like a move towards. Yeah, not the best thing. So the absolute of this guy clamped by like 0 and a 3. So this will be our target here in the volume. We're going to move towards this guy with a speed itself dt. Yeah. So this is like the target, and this is the speed. Well, this is like if val, right? So if val is greater than target, val less than speed. If val is less than target, val is speed. Oh, let's say return. Yeah, return clamp of if we are greater than the target, should really go left, right? Should really go negative. So the clamp should be the target, the val minus the speed, and the positive clamp should be the val. Okay. And if you are less than the target, this should be the val plus speed, which is target, and I'm just going to return. Okay, now we're going to do the simple move towards this guy, moving towards this guy at this speed. Now if we increase the speed, let me turn off the music for a while, please. That was way too much. Let's do like +5. Okay. I think I'm getting somewhere, but this is not 100% because they are like. Why did I get this high? They start going downwards. This should really be like my speed. Let's try to set like the volume D to this guy, and this guy is going to be player volume D times dt. Okay, let's try to clamp this guy. Oh, this is, I thought that was going to be easy. I'm going to move this guy towards, I don't know. I don't know what kind of a math I have to do to kind of smooth this movement. So like the very stupid thing that I can do. Let's do the very stupid thing. Like, yeah, I think that's what I should have done. So I'm gonna add DDP, which is basically just this guy, right? Okay. Now the DDP is going to have, well, kind of did that, the friction. Let's go back to that state. Yeah, kind of this guy. But I'm not going to get the absolute here. Okay. Yeah. And let me go back to the play sound and remove the music. Okay. Okay, let's take out the control that let's take out the control that this guy has. So what I'm going to do is like if this guy is positive, I'm going to add like a fixed. Else. Okay. If you are moving to the right, oh, we should make like else if. This is kind of the weird stuff that gets stuck for like a long time. I don't know if I don't manage to do that, I may just call that a day. We did pretty much everything we wanted to do. Then we maybe do like threading next time, and then we do like a day for just playing around with this kind of stuff. I know this was a victory today, but I really wanted to add this guy because the DP is really messed up. When I did that in the other game, that was really easy because the DP was already smoothed. This DP is raw, I mean. Yeah. Well, we do have the mouse DP. Kind of like that. You know what? I think I just had a golden idea. Like, the volume will just be the mouse will dp.x. Oh man. Why is the mouse world DP so messed up? Let's try to get the actual mouse DP. Let's do that times a very small number. Not that small. So I think I can say for sure that the problem is our mouse input is all over the place. Yeah, since it's not continuous, we can have like 6, 9. Like every frame we have a different value. And what we want, so yeah, found out about that problem. So we can pretty much use the guy down there. Same thing. So the problem is, let me take out this guy. So we're going to get this mic. Oh, well, this sounds perfect. No, it does until we stop. Right. So the problem is, we're going positive 100 if we are moving right. Let's. Oh yeah. Well. We didn't finish this thing, right? Let's do like if it's less than -5. Then 5. Okay. This is pretty decent. I mean, pretty decent. So if I were to change the position based on this would be like a frictionless space. Yeah. Okay, so like that's version 1, which is pretty bad. Now version 2 should be the acceleration equals to this guy. For some reason our loop's not 100% anymore. Let's see if it has to do with our volume. Come on. Well, we do have to set our volume to something. I thought I fixed that. Okay, maybe I'm just tired now at this point. We did a long stream, and we did a lot of stuff. But our loop is not 100%. Let's try going back to the int position. And yeah, plus 1. If we reach the sample count, if we are looping, we go back. Yeah, you know what? We may actually just call this a day. Yeah. But I don't know. I don't like to leave these things kind of unsolved. Put a breakpoint here. Our position is exactly right, and this should be 0. Again. Let's see if I set the pitch speed multiplier to half if we get like a less frequent. Maybe just, yeah, so it is the sound, not the buffer. I suppose that's better. Dude. I really don't know. I really don't know. I really don't know. This looks pretty much perfect. Set that to 0. And then next time around, when we run like this guy, it'll be 0 times what's going to be first sample. Okay, why is the volume that? I suppose it doesn't matter. Why is the volume that? Did I not comment out the volume? No, I didn't comment out the volume. That's weird. I thought I did. Yeah, let's take a step back through all this stuff. Let's do like volume. Movement sound. Let's try playing the music. So we are only doing half the music again. Well, it's good that we found out that problem, but we solved that problem already. Maybe when we introduced something else here, let's see what we changed here. We went back and forth on this for a while, added the volume. Yeah, we refactored this, but I don't know. Yeah, it's sample substitution times 2. So sound position starts out as being 0. 0 times 0. Then we go 1. Then we do 1 times 2, 2. Go 2 and 3. Go 2 times 2, 4, 4 and 5. And this times the channel count, right? So this guy, if we have one channel, we duplicate the same guy. This looks correct. Times the sample count, which also looks correct. Let's do like hard code this guy just to check out this guy. Yeah, well, why didn't we break this guy? I'm really confused. Let's hear the test. Okay, so we are correct. Now let's hear the sign. I don't think we are correct. Yeah, we're not correct. Dude, come on. Let me try debugging that. Let's put a breakpoint here and a breakpoint here. Okay. Start off, position is 0, channel count is 1, so we sample the 0th guy. So the 0 and 0 plus 1 minus 1, so 0 plus 0. Right and the left are the same, so get the sample, and we add 1 to the position. And the position 1, okay. Next time around, sample is 1. Maybe it's greater than the sample count. And we're missing 1 sample. Sample count. Not it, but it didn't crash. That's weird, we should be crashing still. I think I'm gonna sleep on that bug. Because that doesn't make any sense. You know what? Just because we did cheat a few times today, let's go ahead and see if there's anything weird going on. I mean, this is no different. But, well, just let's do it like this. Oh, and actually here we do a free list. Yeah. Okay, maybe we'll do a free list next time. Like the position times the channel count. That's what we do here. And this guy is the position times the channel count plus channel count minus 1. It's the same thing we do here. And then we add the position to the speed multiplier. I don't know what could be wrong. Oh, I'm kind of sad now. Because we got to a great point. I mean, let's go back to adding music, because music's more fun than sign. So yeah, that was really cool. We did a lot, and I don't hear any problems. Maybe I'm gonna listen to that on my speakers. Yeah, it sounds perfect. Let's just one last time hear this guy, the sound of the speakers. Yeah, I can hear it. So, we changed the pitch, implement sound effects, and make the player listening to the padding. Let's also do like fix sign looping problem. Yeah, and then we only need a couple more things from the engine. And also, maybe I should collect like a couple of cool sound effects so we can implement them. And then I'm gonna feel a little bit better about Okay, so I guess that's it for today. We did implement the sound system, the audio, so the whole thing. We implemented like using the library. Then we did our own mixer that can read files and decode waves, and we did all sorts of stuff today. We're not 100% yet, but we're getting there. Okay, so if you enjoyed the stream, you can watch out the whole. You can watch the whole other streams where we created the game. We started out with a blank file, did all the way to where we are now. We did like bitmaps and audio, things like that. And and you can watch the whole thing on YouTube, which is youtube.com/danzaydan. And then you can download the game on itch.io. You can go to danzaydan.itch.io, come here to click on the game, and you can see not only like the full source code. Every day has its own source code. So in the first day, they implement like the basics, like a window and a render. You can download that source code, and all source codes, including I'm gonna post like today's source code, along with the files. So hopefully you can learn along and also have fun. So that's it for this stream. Next stream we're gonna do threading probably, and maybe fix this problem. Not sure. Okay, so thank you all for watching, and I hope to see you guys next time.